Hi, my name is Justine Harkness, and in this video, we'll learn how to name alkynes. To name an alkyne, what you first want to do is identify the longest chain that contains the triple bond, and then number that chain such that the triple bond has the lowest number. You'll indicate where that triple bond is and the fact that it's present using the YN infix. And if you're not familiar with the difference between suffixes and infixes, let's review that real quick. So say we have a just hexane. If this was instead having an alcohol, say you had an OL somewhere, what you would do is you would replace the E with an OL, and that would be what we would consider a suffix because it's at the end of the molecule. So that would be suffix. The difference with an infix is instead of replacing at the end of the molecule, what you do instead is replace that AN with a YN. So that would be the infix because it's in the middle of the name, not at the end. And for the rest of the nomenclature, you would just use normal conventions for naming the substituents. Now things get a little bit more interesting when you have molecules that contain both double and triple bonds, because in terms of priority, double and triple bonds are considered equal. So in our naming, we have to use the lowest sum rule, and this is where we number the carbons so that we have the lowest sum of numbers overall. And let's take a look at this molecule and use it as an example to illustrate this point. Now, if we were to number this molecule from left to right, here in purple, we would have a sum of 1 for the double bond, 3 for the second double bond, and then 6 for that triple bond. And that would give us an overall sum of 10. But let's see what happens if we label from right to left. Now, in this case, notice that we have the alkyne, that triple bond, as number 1, and then we have the double bonds on carbons 4 and 6. So here the sum is 11. So because we want to have the lowest sum overall, we would want to go with the numbering from left to right. And we'll have some cases where we have the same sum as we look at some examples, and we can explore what to do in that case when we get to it. So let's tackle some examples. So let's name some molecules. And let's start with example A. Now, example A has a triple bond, and notice that it's located at the very end of this molecule. This is what we would term a terminal alkyne, since our triple bond's at the very end. Now we have to number it such that the triple bond gets the lowest possible number. So we'll number this guy from right to left. Here we have 5 carbons in our parent chain, so this would be a pent. And because of that triple bond, we use YN instead of AN as the infix. And then lastly, we have to denote where on that molecule that triple bond is located. And here it's on carbon 1. So this would be a 1-pentyne. Now let's take a look at B. B is a little bit more interesting, and it's because it has both double and triple bonds. And notice that the double and triple bonds pretty much alternate down the molecule. This is going to bring us to an interesting point, and let's explore that. So if we start numbering, we'll first start by numbering from left to right. We have pi bonds, either double or triple, on carbons 1, 3, and 5. So the total sum here would be 9. Now let's see what the sum would be labeling in the opposite direction, from right to left. So here we have double bonds on carbons 1 and 3 and a triple bond on carbon 5. So the sum is also 9. And here we have a tie So we need to think about our tiebreaker. And that comes into the alphabetical order. If we were to just name these, as numbered, in red we would have a hexa. Note, the A is just there for the ease of pronunciation. It rolls off the tongue a little bit more readily. We have 3 5-ene, 1 ine. But if we were to use blue numbering, we have a hexa 1 3-ene, 5 ine. Now, E becomes before Y in the alphabet, so we want to have lower numbers for the lower letter. So in this case, because of that extra alphabetizing rule, the 1 3-ene, 5 ine would be the correct way to name this. So anytime that you have a tie in your lowest sum rule, the breaker for that is alphabetizing. So the double bond would get the lower number because it comes earlier in the alphabet. And we see that again with C. We want to number this. Notice both of these double and triple bonds are terminal. So the sum rule would be the same just like it was in B. We're going to number this so that the double bond has the lower number. So this would be a but 1 ene, 3 ine. So now you should feel more comfortable naming alkynes.